So let's try and take a specific logarithm and break it down a little bit more. Let's look at log base 3 of x as a function. All right, so I'm going to make a table. So first I'm going to take some values of x. Okay, so then log base 3 of -2. What does that mean? It means what power do I raise 3 to get -2? That's problematic. To help see this a little bit more clearly, let's put this in exponential form. So this is the exponential form of log base 3 of -2. So 3 to what power equals -2? If we raise 3 to a positive power, it's just going to get bigger, and it won't become negative. If we raise it to 0, it'll just be 1. And then if we raise 3 to a negative exponent, it will be smaller, but it still won't be negative. So here's our number one thing about logarithms. Their domain is restricted from 0 to infinity. We can include everything except 0 and any positive number. We just can't include 0, and we can't include any negative numbers when we plug into a logarithm. Now the reason we can't include 0 is for the same reason we can't have -2. You can't raise a number to a power, whether that power is positive or negative, and get 0. You could plug in, say, 3 to the -1000th, and it'll be very close to 0, but it still won't actually be 0. Okay, so if you're plugging numbers into a logarithm, it needs to be greater than 0. Now, back to our table. This is the mistake most students make when they're trying to graph a logarithm, is they pick values for x and then try to figure out what the log of that x is. That's the wrong way to go about it. Let's try a new way. Let's actually plug in on the right-hand side of the table first, like so. All right, let's put this in exponential form and make even more sense out of it. So we've got log base 3 of x equals -2. Log base 3 of x equals -1. Let's put these up here in exponential form. Okay, so here they are in a side-by-side comparison. Log base 3 of x equals -2, so just taking from our table, gives us the equivalent equation 3 to the -2 equals x. 3 to the -2 is 1/9, so we can fill in the left-hand side of our table here. Next up, 3 to the -1 equals x is the equivalent equation for log base 3 of x equals -1. So what we're asking here is 3 to the -1 power equals x, remember. Exactly what we have. 3 to the -1 is 1/3. Likewise, 3 to the 0 is 1. 3 to the 1st is 3. And 3 squared is 9. So when you fill in the right-hand side first, it's a lot easier to fill out what your x is. If you go the other way, you could end up with some problems, even beyond the negative numbers. Say, for example, you plugged in 4 for x. While this doesn't seem problematic, let me put it in exponential form, then you'll see why this is an issue. We're looking for an exponent to raise 3 to get 4. If we square 3, we get 9, and 3 to the 1st is 3. So that exponent is going to be a decimal number, and it's going to be a weird decimal number, not one that's going to be easy to calculate by hand. So if you're trying to sketch a graph of a logarithm, make it easy on yourself and choose powers of 3 to plug in. For example, you know that 27 is 3 cubed. So if you plug in 27 for x, you raise 3 to the 3rd power to get 27. So you can make life a lot easier by picking powers of 3 to plug in for x, or powers of whatever your base is. If your base is 2 or 5, you would pick powers of 2 or 5. All right, so let's take a look at this graph, see what it looks like.